Hi, welcome to video 1.3D. This is our trig limits. Now we've done a few easy trig limits. These are going to be a little bit more complicated. So we talked about this at the last video on 1.3, which would have been 1.3C. So let me do that. Okay. We have the limit as x approaches 0 of sine x over x. Keep in mind, of course, that when we plug in 0, we will get sine 0 over 0, which will be 0 over 0. So what will happen when we get 0 over 0 is, what can we do? So remember what we said was, of course, looking at this expression right here, we can't factor it, we can't simplify it, we can't rationalize it. So for now, we're just going to say that we're going to look at the graph and realize that as we get closer and closer to 0 from both sides of the graph of y equals sine x over x, it appears to approach 1. So for right now, we're just going to accept that as a fact, and that is the limit you need to know right here. The limit as x approaches 0 of sine x over x equals 1. Now you'll notice I have blue boxes around these three x's, and that's because these three blue boxes each have to contain the same expression. For example, if this is 2x in this box, it has to be 2x in that box, it has to be 2x in that box. The other thing that's very important is that this is only true if it's the limit as x approaches 0. If this was the limit as x approaches any other number but 0, your denominator would not be 0, you'd have an actual value. The other one we looked at was the limit as x approaches 0, again, of 1 minus cos x over x. Again, the three black boxes here have to contain the exact same algebraic expression. And, of course, again, this has to approach 0. Now, again, if we did plain old substitution, we get 1 minus the cosine of 0. The cosine of 0 is 1, and we would end up with 0 over 0. So, again, we looked at it graphically, and it appears that as x approaches 0 from the right and from the left, just connect that here, that it appears it approaches 0. So we have the limit as x approaches 0 of 1 minus cos x over x equals 0. Okay, so what we have here are examples of what they're going to have you do with this. So again, in every single case here, if we replaced x by 0, we would get 0 over 0. So what we have to do is we have to get it to look like the actual one of the two expressions. So we are able to pull out the 3. It's going to come back. We are able to pull out the 3 by the properties of limits, and therefore we end up with the limit 3 times the limit as x approaches 0 of sine x over x. I can't seem to get this to work very well. And of course that expression over here is, this expression in this parentheses is what's equal to 1, so we have 3 times 1 is 3. The thing I want to caution you about up here is a very common mistake. People rewrite the sine of 2x. They think, oh look, I can just pull the 2 on the outside. That is not true. If you remember your formula for the double angle, the sine of 2x is 2 sine x cos x. It is not 2 sine x. The cosine of 3x is not 3 times the cosine of x. Now, what will happen is in certain easy examples, you will make this mistake and get the correct answer by fluke, but I will ask to see your work, and if you replace the cosine of 3x by 3 cos x, I have got to take points off. Okay, the next example, we're going to be able to pull out the 3/5, and the beauty of that is when we do, again, all of this is exactly the formula that we know, so we end up with 3/5 times 1, which is 3. Okay. All right, here's another example. Now, this is a much trickier example, okay? We certainly can pull out the 4, that we're allowed to do, but remember, we cannot pull out the 3 because sine 3x is not 3 sine x. So what we have in the blue box is 3x. So what we need here is we need another blue box. Sorry about that. We need another blue box here, but it has to have 3x in it, and we need another blue box here. It also has to have 3x in it. So here's what we're going to do. We're going to pull out the 4. As you can see, I pulled out the 4. Now the next thing I'm going to do is I need to introduce a 3x up here. Remember, the boxes have to be all the same. So by introducing a times 3, I have to counteract that by introducing a 1/3. Therefore, I have 1/3 times 3, which is 1, so I haven't really changed anything. As far as this box here needing to be 3x, that's not a problem, because as x gets closer and closer to 0, any number times x will keep getting closer and closer to 0. So we end up with 4/3 on the outside, and then of course the limit is 3x approaches 0 of 3x over sine 3x, which is 1. Okay? And that'll give you 4/3. Now, I just want to point out, had you pulled out the 4 and mistakenly thought you could pull out the 3, you actually would get 4/3, but the work you will have done will be wrong. Okay, again, I'm trying to remind you of this. Do not do that. So here are our two expressions that we know, our two formulas, if you wish. So now they're going to get a little bit more complicated. The sine of 2x over the sine of 3x. I cannot pull out the 2 and the 3. Substitution would yield 0 over 0. So what we're going to do is we're going to have to actually work with each one of those kind of separately. So I have the sine of 2x here, and I have the sine of 3x here. Now what I'm going to do is I'm going to multiply top and bottom by 1 over x. The reason is I do need to at some point end up with the sine of 2x over 2x for this one, with 2x here. And for this one I need to end up with, ooh, sorry, I don't know how that happened. Let me undo that. Okay, let me put it here, and I think we're safer. Okay, so over here I also need to end up with sine 3x over 3x. So I know I need 2x as a denominator under here and 3x as a denominator under here. So the first thing I'm going to do is multiply top and bottom by 1 over x. So at least now I have the x. The next thing I'm going to have to do is I need a 2x down here in this green box. So in effect I'm not introducing a 2 because it's in a denominator, I'm introducing a half. Therefore, I have to counteract it with 2 because 2 times a half is 1. And again, as x goes to 0, as we said over here, 2x will also go to 0. So now they all match, so this parentheses will equal 1. We do the same thing on the bottom. We already have the x that we introduced. We need the box on the bottom to be 3x. Right now it's x, so I need to introduce a 1/3, counteract with a 3, and of course as x goes to 0, so does 3x. So you end up with, finally, 2 times that parentheses, which of course is 2 times 1, and on the bottom you have 3 times 1, and therefore you get 2/3. And that's the end of video 1.3D. Nice short video.